Okay, so let's continue talking about circles. And if you recall from the last couple of sections, we have been talking about central angles. And if you remember, a central angle, if we have a circle with a center, a central angle is an angle whose vertex is at the center of the circle. And we learned also that if the central angle had a measure of, say, 80 degrees, the measure of the arc that it intercepted was also 80 degrees. Okay, so with a central angle, that means that it's going to be in the center of the circle, and the arc and the angle measure are going to have the same measure. Okay, now we're going to shift our brains just a little bit, and we are going to talk about an inscribed angle. Okay, and again, we are going to have a circle. And here's the center of our circle. However, an inscribed angle does not have the vertex at the center of the circle. An inscribed angle has the vertex on the circle, which means we're going to have something that looks like that. And then what we're going to learn here in just a second is how we can figure out the measure of that arc right there. So an inscribed angle has its vertex on the circle. A central angle has its vertex in the center of the circle. Okay, so what we're going to find here is we have an inscribed angle. That's just basically defining what we just talked about, what it is. It's got the sides are the chords of the circle, and then the arc that lies between them is called the intercepted arc. And subtend, that basically means if the endpoints of a chord lie on the sides of an inscribed angle, then the chords are said to subtend the angle. Okay, that's just a lot of vocabulary to say what we just said on the last slide, that basically an inscribed angle has its vertex on the circle, and then what we call the arc here is called the intercepted arc. And what you find about an inscribed angle and its intercepted arc is that the measure of the angle is half the measure of the arc. So kind of think about it two ways. It means that the measure of the angle, like the central angle, or excuse me, not the central angle, the measure of the inscribed angle is half the measure of the arc. Which conversely means the measure of the arc is 2 times the measure of the angle. Of the inscribed angle. So let's take a look at how that actually works. Okay, so here I have a circle with some chords in it and things like that, and it asks us to find the measure of an angle and the measure of a arc. Okay, so keeping in mind, part A asks for the measure of angle T. So let's look here. I want to find angle T. That would be this angle right here. I know that the arc that it intercepts is 48 degrees. So I know the measure of my inscribed angle equals half the measure of my arc. So therefore angle T is going to be half of the arc. That arc is 48. So my angle is going to be half that, which is going to be 24 degrees. So over here, angle T is going to be 24 degrees. And going the other way, thinking the other way, I want to know the measure of arc QR. Okay, so let's find what we're actually talking about here, arc QR. Okay, well, I don't have an inscribed angle. Just looking at it, I don't have an inscribed angle that will be easy for me to figure out what the measure actually is. So let's think for just a second here. Okay, so let's look at our diagram here and think, what can I actually figure out and what do I know? Because when you look at these diagrams, it's important to think about what you know and what you can use in order to figure that out? Well, I know I have a 50-degree angle right here. And I know I have this is my inscribed angle that's making that 50 degrees. So what I do know is that QT from here to here is twice my angle. So this is going to be 100. But then I have to think, how could I figure out QR? Okay, well, what's this right here? It's a chord that goes through the center of the circle. It's a diameter. Well, if I have a diameter, the measure of my arc that it intercepts is 180 degrees. So I know that that green arc I just had there was 180 degrees, which means if this is 100, I would know it'd have to be 80 degrees. So the measure of arc QR is 80 degrees. Again, make sure you are reading the question and not just assuming it was asking about QT. QT would have been super easy to figure out. QR made us think just a little bit. Okay. So then this one basically says, if two inscribed angles of a circle intercept the same arc, then their angles are congruent. So if you look, we have arc GH right here, okay? And you have, in blue, this angle is 75 degrees. And then you also have this angle right here, which intercepts the same arc. Okay, the endpoints of that green angle are also at G and H, which means if this angle is 75 degrees, then angle F is also going to be 75 degrees. So let's take a look and just do a couple of examples of this. Why don't you go ahead and pause the video, stop for a second, and actually try to do them on your own, and then come back. If you have questions on how to do them or anything like that, please ask. Otherwise, I will kind of guide you through them here in just a second, but I would like you to try them on your own first. Okay, so I have an inscribed angle here, and it intercepts an arc that is 90 degrees. I know if my arc is 90 degrees, my inscribed angle is going to be half that, which means it's going to be 90 divided by 2, which is 45 degrees. Okay, look again here. Now on the second one, you have that this angle, let's see here, this angle right here is 38 degrees, and the arc it intercepts is going to be double that. So we would have 38 times 2, which is going to be 76 degrees. All right, and then our last one here, I have this angle that is 72 degrees. I also have this one, I'm going to make it blue now. They both intercept arc ZW, which means they intercept the same arc, which means if Y is 72 degrees, X is also going to be 72 degrees. Okay, moving on here. What we have is if you have a right triangle in a circle, then the hypotenuse is a diameter. Okay, and some things that we know is that a diameter, if we look at this, we know that the diameter right here intercepts an arc that is 180 degrees. We learned that about diameters. We also now know that this inscribed angle, remember it goes from here to here, is half of 180, which is 90, which is how we know that it's a right triangle. Okay, so if you have a right triangle in a circle, that means that the hypotenuse is going to be a diameter. The other idea here is that if you have a quadrilateral inside of a circle, okay, so notice we have a quadrilateral, it has 4 sides. It's not necessarily a square or a parallelogram or anything like that we can tell. But if it is inscribed in a circle, that means the opposite angles are supplementary. And remember, supplementary means adds up to 180 degrees. So that means E plus G would add up to 180, and also D plus F would add up to equal 180 degrees. So let's take a look at some examples of that. Okay, so the first thing I know here is I have a triangle and a circle. Oh, look at that, which means I know that if I have a triangle inside of a circle, that it's a right triangle. Okay, I know that this is a diameter. I know that this is 180 degrees because it's a diameter, which means I also know that it's a right triangle, and if this is 180, this is going to be 90 degrees, so I know that 2x equals 90 degrees, and x equals 45. Okay, so this second one here, I have a circle, and there's a quadrilateral inside of it, which means if I have a quadrilateral inside of a circle, then I know the opposite angles are going to be supplementary. So I know that z plus 80 is going to equal 180, so z is going to be 100. Okay, and let's think about what else that tells me. If I know that angle z from here to here is 100 degrees, that's 100. Then I also know that the arc it intercepts is going to be double that. So I know that this whole arc right here would be 200 degrees. So just some other things that we can figure out. So I know that that blue arc that I just drew in there would be 200 degrees. So then let's erase some of these diagrams that I have on here. I am going to leave that blue that says that's 200 degrees. From here over to here is 200 degrees. And I also can say that I know the other pair of opposite angles. I have y and 120. So I know that y plus 120, oops, not equals, y plus 120 is going to equal 180. So I know that y equals 60. So I know that this angle is 60 degrees. And if you look at the arc that it intercepts, I know that from here to here is going to be double that, so I know that that's going to be 120 degrees. So there's some things that we can actually figure out about arcs, as well as the measure of the angles inside of the quadrilateral. All right, let's just go through a couple more examples. Actually, why don't you go ahead, like I said before, if you want to pause the video, try them on your own, and then play again, and you can kind of see an example or an explanation of how to actually do them. That's fine. So if you want to, pause the video and try them on your own. Okay, so I have, first thing, I have a circle with a triangle in it. If it's a circle with a triangle in it, that means I know that the hypotenuse is the diameter, which means I know that if the hypotenuse is the diameter, it's a right triangle, so that tells me that x equals 90. So I know it's a right triangle, x equals 90. And again, just knowing some things that we remember is I have a triangle. I know one angle is 90 degrees, one angle is 40 degrees. And then I have y, which means 90 plus 40 is 130, plus y is equaling 180 because it's a triangle sum, so y is going to equal 50. So not everything is new material. Some things you have to go back and remember things that we've learned previously in the year. Supplementary angles, triangle sum, all those kind of things. The algebra stuff that we learned previously that you learned in Algebra 1 that you're using now when you have to solve equations 2 in geometry. Okay, so here we have a circle with a quadrilateral, a four-sided shape in it, which means, thinking back, I know that the opposite angles are going to be supplementary. So I know that y plus 68 is going to equal 180. And then I also know that x plus 82 will equal 180. So that tells me if I subtract 82 from both sides, x is going to be 98. And if I subtract 68 from both sides, that tells me, let's see here, y is going to be 112. Okay, one more last example here. is I have a quadrilateral and a circle, which means I'm going to have opposite angles are going to add to 180. Okay, so I'm going to say C plus 2C minus 6. If I put my terms together, I get 3C minus 6 equals 180. If I add 6 to both sides, oops, that would be 186. There we go. And 186, let's see, what is that? 186 divided by 3 is 62. So C is going to equal 62. And the other one here, my other pair of opposite angles are 8x and 10x, so I know that they are opposite and they add up to 180. So I'd have 8x plus 10x would be 18x equals 180. If I divide by 18, I get x equals 10. Okay, there is once again, a class kick for you to work on, so please get started on that and ask any questions if you need to.